Hello and welcome to Math World. Let's talk about distributive property. Distributive property is just a way for us to multiply when we have parentheses. So if we have a problem that has parentheses in it, we can actually get rid of this parentheses by using the distributive property. So let's see how it works. Let's take this problem, 5 times 2 plus 4. Remember, any number next to a parentheses with no operation in between it means multiply. Alright, if I were to solve this regularly, like you would probably think to do it, you would do 2 plus 4, which is 6, and 5 times 6 is 30. Now let's see what this looks like as distributive property. Distributive property says we should multiply each of the terms inside of the parentheses by the number on the outside, by the term on the outside of the parentheses. And so what I'll do is I'll take 5 and multiply it by 2, 5 times 2, and I'll take this operation, add, and also multiply 5 times 4. 5 times 4. So you see I multiplied 5 by 2 and by 4. I distributed the 5 to the 2 and to the 4. 5 times 2 is 10. 5 times 4 is 20, using our PEMDAS rules. And 10 plus 20 is 30. So you see it works. Alright, now how does this look like in algebra when we have variables? So let's try 2 times 4x minus 3. Well, again, I'm going to multiply everything inside the parentheses by the number on the outside. First, 2 times 4x. 2 times 4x gives me 8x. Also, 2 times negative 3. This term is negative 3 or minus 3. So, minus 2 times 3 is 6. I'll bring down this minus 6. And let's see, 8x minus 6, can I take that any farther? Are those like terms? They're not like terms, so it's done. That is my answer. So there's the distributive property. Well, that's it, and I'll see you in class. Hey class, it's Mr. Bigsby with a hat, and I'm here to give you a challenge question. Alright, so everyone's been saying that they want a little bit harder problems, so let's see if you can solve this one. Negative 2 times 6 minus 3y equals 5 times 2y minus 7. See if you can solve for y. What is this missing number? So you're going to have to use distributive property here and a little bit of combined like terms from the last lesson, and of course, inverse operation. Alright, see if you can leave the answer in the comments. Later. Now for a word from our sponsor, Paper Cut Games. Now I know you all like card games, so this week is an old school little travel game called No Thanks. Now in this game, there's going to be a deck of cards that they're going to remove a couple of random ones so that you don't know all the cards in the deck, but the numbers are 1 through 36. And each time a card's going to come out, and the players will kind of say whether they want to take the card and add to their stack of points or say no thanks. And if you say no thanks, you take one of your chips and you put it on the card. Now the goal is actually to not get points. So you don't want the cards, especially a high one like 35. Now people will say no thanks as they go around because nobody wants the 35, right? But eventually you're going to run out of chips. Or maybe you don't want to use all your chips up. You only start with about 8 chips. Or maybe you see 5 chips on there, because if you take this card, not only do you get the card, but you get all the chips. So yeah, you got 35 points, which stinks, but you have more no thanks power. And so each time a new card will come over, a 9, and players will take turns basically saying how many times they can say no to that card. Although a 9 maybe I want to take and pick up the 2 chips that come with it. So it's kind of an interesting game, and there's a couple scoring tricks, like if you get things in a row, it doesn't hurt you. And the goal is to say no thanks and not get the cards, not get the points. So easy little travel game, no thanks. Check it out. I'm Mr. Bigsby, and I approve this message.